Hi, in this video we will see about the electrochemistry. Electrochemistry is the third chapter from 12th standard. So, what is electrochemistry? Electrochemistry is the study of electricity in a chemical reaction. Okay, there are n number of chemical reactions. So, certain reactions will generate the electricity and some of the reactions will perform through the electricity, and such reactions are called as electrochemical reactions, right? Okay, there are two types of reactions. One is spontaneous reaction and another one is a non-spontaneous reaction. Whereas a spontaneous reaction, there will be the generation of electricity. Through this reaction, the electrons will be produced and hence there will be a current generation, right? And another reaction is a non-spontaneous chemical reactions. That is, if we supply the external energy, that is an electrical energy, the reaction will perform, else it will not perform. As we have seen two types of chemical reactions, that is the two types of electrochemical reactions, like a spontaneous and a non-spontaneous reaction. How these reactions are performed? Through two processes, that is an oxidation and a reduction. What is oxidation? Oxidation is a loss of electron. Okay, oxidation is a loss of electron, whereas the reduction is a gain of electron. As you see here in this screen, you can see zinc. Zinc, when reacted with hydrogen to give zinc ion, that is zinc 2 plus ion and hydrogen as a gas. Here what it happens? Zinc is oxidized as a zinc 2 plus, that is loss of electron. It loses 2 electron to form zinc ion, right? And whereas as hydrogen is reduced, that is it gains the electron from the zinc to form a hydrogen gas. Okay, right. In parallel, you can understand some of the things like oxidizing agent and reducing agent. H plus ion is an oxidizing agent. Why? It makes the loss of electron from zinc. That is, it oxidizes the zinc, and hence it is an oxidizing agent. This makes the oxidation. The hydrogen ion makes the oxidation, and hence the hydrogen ion is called as an oxidizing agent. That is, it is get reduced. Whereas the reducing agent is the one is a zinc, because it reduces the H plus ion to hydrogen gas. Okay, that is hydrogen ion gains the electron, and which makes the hydrogen ion to hydrogen gas zinc. So zinc is a reducing agent, whereas the H plus ion is an oxidizing agent. Okay, right. We have seen spontaneous reaction and non-spontaneous reaction, but where we have seen this spontaneous reaction, or where we can demonstrate this spontaneous reaction or non-spontaneous reaction, how we can experience these types of reaction. These reactions can be performed or demonstrated through some device. For example, the spontaneous reactions are demonstrated through the galvanic cell or voltaic cell, and in these galvanic cells there will be the potential will be created through the chemical reaction. That is, the electricity is generated, and through that electricity the potential will be developed between the two electrodes. And for the non-spontaneous reaction, there is a device called the electrolytic cell, which it will supply the electricity to perform the non-spontaneous reaction. The electrochemical reactions can be understood through the electrochemical cell. we can take a Daniell cell and we can take an example of chemical reactions between zinc and the copper. In this electrochemical cell, that is in Daniell cell, there will be two half cells. One half cell contain one electrode and another half cell contain another electrode. The electrode which makes an oxidation, and that electrode is called as an anode. In this example, zinc plays a role as an anode because it has a low potential, and copper is act as a cathode because in the copper there will be a reduction takes place. Okay, we will also see some of the basic information for the electrochemical cells because by understanding these terminologies or this information, we can understand the process of electrochemical reactions, right? Okay, the another thing is an electrode potential. What is an electrode potential? There is a potential difference between the electrode and electrolyte. It's called as electrode potential. The electrode is a solid metal, okay, and the electrolyte is a ion of that electrode. Say for an example, zinc is an electrode, anode, whereas the zinc ion is a electrolyte. Okay, the potential difference between the zinc and zinc ion is called as electrode potential. Okay, what is the standard electrode potential? Standard electrode potential is the potential difference between the electrode and the electrolyte when the concentration of the electrolyte is unity, that is 1 millimolar, then it is said to be a standard electrode potential. So, as we see the reaction between the zinc and copper, zinc is oxidized. Zinc is oxidized to zinc ion, zinc 2 plus ion, and it loses 2 electron. Whereas the copper is reduced to copper solid, reduced to copper solid. That is, we can see in the picture. In the picture, you can see the oxidation and reduction. What will happen? What the ion when the ion moves? What will happen to the anode and what will happen to the cathode? Let me see in the next video. This picture is a Daniell cell. In this, the left compartment, as you seeing the zinc electrode as a anode and the copper electrode is a cathode. The zinc in the anode compartment you have zinc sulfate. In the cathode compartment you have copper sulfate. How this how the electrolyte is showing as a zinc ion and the sulfate ion, not as a zinc sulfate. It will split into zinc and sulfate ion in the solution. Okay, then during when we connect the two electrode, what will happen? There is a potential difference will be created between the two electrode. That is, zinc has the low potential, that is a negative potential, whereas the copper has a higher potential of positive potential. Due to this potential difference, there will be a generation of current. How it will happen? Zinc will oxidize to zinc ion. Okay, that is, it will lose the 2 electron in the electrode and it will be removed as a zinc ion, zinc 2 plus ion in the solution. Okay, during this process the zinc is depleted. Okay, zinc is depleted as you seeing in the next figure. The zinc is depleted to zinc ion. How the electrode will be changed? Electrode is depleted. That is, a zinc electrode is depleted. That is, it become lean because the zinc, all the zinc ion when it gets oxidized means it will be turned as a zinc ion in the aqueous solution, and hence it will be in the aqueous phase, not in the solid phase, so that the size of the electrode is depleted. Okay. In controversial to this, these electrons are transferred to the copper. The copper is reduced as a copper solid. So what will happen? These copper ion will get attached to the copper electrode, and you can see in the last picture the copper is deposited, that is, it gets bulged as a copper ion. Why? The electron is transferred through the copper ion, and hence it converted as a copper solid. When the electron moves from the zinc electrode to copper electrode, the flow of current is in the direction opposite to that of the flow of electron. That is, the current flow is from the copper to zinc, and there will be during this process there will be a potential difference between the two electrodes. There is the potential will be developed between the two electrodes, and that potential is called as a cell potential. The cell potential is the potential difference between the zinc and the copper electrode, that is the anode, and the potential difference between the anode and the cathode is called as a cell potential. Okay. Generally they will call the cell potential as a electrode potential of right and minus the electrode potential of left, because in the left direction there will be an anode, right direction it is a cathode. So cathode minus anode will give the cell potential. You can also remember this cell potential as a higher potential minus lower potential as a cell potential. During this electrochemical reaction, that is, the electrons will flow from the anode to cathode, and the current will move from the cathode to anode. These two half cells are connected by the salt bridge. Salt bridge is one which is connecting the two electrolyte solution. Okay, the two electrodes are connected by the wire. In that wire, you have a potentiometer. That is what is the potential created will be shown in that meter, right? Whereas the electrolytes are connected by the salt bridge, because it will transfer the sulfate ion from the cathode to anode. Okay, and not only for this, it can be when the salt bridge is connected, the circuit will be completed, else the circuit will not be completed. Okay, it will be in a open circuit. If the salt bridge is not there, then it will be a open circuit. If the salt bridge is present, then it will be a closed circuit. Okay. Representation of electrochemical cell. We have seen the reaction between the zinc and the copper for the Daniell cell. Okay, how it can be represented in a written form? It can be represented as for the zinc. The zinc should be represented in the left hand direction as a zinc solid. Okay, the anode is represented as in the left direction, and its ion is separated by a vertical line, because the ion is an electrolyte which is in the aqueous phase. It is not in the solid phase, and these zinc ion and copper ion is separated by two vertical line, that is a double vertical line, because zinc is in anodic compartment and copper is in the cathodic compartment, and which is further separated through the another vertical line between the copper and copper ion. Hydrogen electrode as a reference half cell. How the hydrogen electrode acts as a reference of cell? Let me see. We know the formula. In the bottom I have given the formula. We have already seen the E cell is equal to ER minus EL. Okay, that is the cell potential is the difference, potential difference between the cathode minus anode. That is electrode potential of right side minus electrode potential of left side. Okay, how the cell potential is determined? See, the cell potential is not determined value. It is a measurement value which is shown by the meter. Okay, from that cell potential we cannot able to determine the standard electrode potential of any electrode, either the cathode or anode. We cannot determine from the cell potential. Why? Take an example. If the meter shows 10 volt means the 10 volt can be achieved by many standard electrode potentials. For example, if the 10 volt can be achieved by 14 volt minus 4 volt is also 10 volt. 13 volt minus 3 volt is also 10 volt. 12 volt minus 2 volt is also 10 volt. 8 volt minus of minus 2 volt is also 10 volt. So the standard electrode potential may vary for right hand side and left hand side. We could not able to determine it through the cell potential, but we can determine the standard electrode potential through the hydrogen electrode. How? Let me see. First we will see the setup of a hydrogen electrode. Hydrogen electrode always acts as a anode. Okay, always it will act as an anode, and it has a platinum wire as an electrode. The hydrogen gas will be passed through it, which is maintained by 1 molar of hydrogen ion. This hydrogen ion will get the electron and form as a hydrogen gas. Okay, we will see the how the hydrogen electrode will shows the unknown potential of other electrode. That is, unknown potential of any electrode can be determined through the hydrogen electrode. We will see it. The standard electrode potential of hydrogen is 0. Okay, 0 voltage. We know the formula E naught cell is equal to E naught R minus E naught L. Here we know two things. One is a standard hydrogen electrode potential, that is a 0 volt, and we also know the hydrogen acts as an anode. Okay, that is, it is a E naught L. Okay, substitute the value in the E naught L. It will give the value of unknown electrode potential of cathode. Okay, where we get the cell potential? Cell potential can be displayed in the meter. Okay, whatever the cell potential shown in the meter will be equal to the standard electrode potential of that cathode when you connect it with the hydrogen electrode. Okay, so if you don't know the potential of any electrode, connect it with the hydrogen, whatever the cell potential, that is EMF of the cell will show, means that potential will be equal to the standard electrode potential of that unknown metal. What is the standard electrode potential? Standard electrode potential is the one which is maintained in the unit concentration, that is the 1 molar concentration of electrolyte. Okay, so we don't know the electrode potential of a copper and anode. When we connect the copper with the hydrogen and when we connect the zinc with the hydrogen, we can able to determine its electrode potential, standard electrode potential of copper and zinc. As I highlighted in the blue color for the copper, which is connected to the hydrogen, as like same in the Daniel cell we connected the copper and zinc. The EMF of cell will be shown in the meter. It will display 0.3 volt. Okay, and we know the hydrogen electrode potential, that is standard hydrogen electrode potential is 0 volt. When you apply in that formula, you will get the standard electrode potential of copper will be 0.34 volt. Similarly, if you connect with zinc with the hydrogen electrode, means it will shows the standard electrode potential of zinc will be minus 0.76 voltage. Okay, and here you have to understand the other thing. The copper is having a higher potential. Okay, that is 0.34 volt, which is greater than that of a 0 volt than the hydrogen. In lower classes we have studied metal reacts with acid to give a hydrogen and salt. Okay, here the metal is a copper and acid is a H plus ion is a acid. Okay, if you take the HCl copper, if you take the HCl and put it in the copper, means copper will not react with HCl to form copper ion or hydrogen gas. It will not liberate the hydrogen gas. Why? Because it is having the higher potential. The one which is having the higher potential will always be reduced. Remember, the potential which is always the electrode which is having the higher potential is always reduced, and the lower potential is always oxidized. Okay, here in this condition the copper is having higher potential. It will not be oxidized. Okay, it will be reduced, so it will not oxidized to copper ion. Okay, but when you use the nitric acid is also having the H plus ion, but in this condition it will oxidize to the copper ion and liberates the hydrogen, and hydrogen is reduced as a hydrogen ion is reduced to hydrogen gas. In this condition you can see the reaction as the reaction will perform. Okay, how it will happen here also the potential is higher. Okay, in this condition it will happen because of the nitrate ion. Nitrate ion is having the power to oxidize the copper ion, not because of the H plus ion, because H plus ion is always lower potential. Okay, so now we know the standard electrode potential of a zinc and copper. We know the formula. E cell is equal to E R naught minus E naught L. Okay, substitute the values and we will get the standard cell potential of that cell between the zinc and electrode is 1.1 volt. Okay, which is maintained in the unit concentration. That is, we are maintaining the 1 molar concentration of zinc ion and 1 molar concentration of copper ion in the two compartments, means then the resultant cell potential will be 1.1 volt. Here we will see three conditions when we apply this external potential that will make a change in the electrochemical cell. In figure A, you can see this external potential which is lesser than that of 1.1 volt. Take an example. If you apply 1 volt which is lesser than 1.1 volt, in this condition it cannot neither reverse the reaction nor stop the reaction. That is, if you take an example between the two person who is having strength difference, one is having the lower strength, another one is having higher strength. If the lower strength person tries to pull the person, means he can't able to put, but instead the the person which is having the higher strength, he can push the lower person. Okay, so the same condition can be seen here. Similarly, here the potential external potential we applied is 1 volt, which is lesser. It cannot neither reverse or stop the cell potential. So the whatever the things happen already is going to happen. That is, the depletion of zinc will happen and the deposition of copper will happen. Similarly, the electron flows from the zinc to copper and the current moves from the cathode to anode. In the figure B, if you apply the cell external potential which is equal to the 1.1 volt, the two electrical potentials are equal, and hence there will be no flow of current, no flow of electron, no depletion nor the deposition. Okay, take that same example. If the two persons are having same strength, no one can pull each other, okay, the both of them in the same position because they are having same strength. And in the C figure you can see the external potential is greater than that of 1.1 volt. If you apply the 1.2 volt, which is greater than that of 1.1 volt, then the reaction is getting reversed. That is, cathode is become anode, anode is become cathode. Now the zinc is become cathode, copper is become anode, okay. Then the electron moves from the copper to cathode and the current moves from the cathode to anode, that is from the zinc to copper. Here the deposition of zinc occurs, whereas in earlier case the deposition of copper will occurs. Here the deposition of zinc will occurs, and instead and in contrast the depletion of copper will occur. That is, the copper is getting oxidized and the zinc is getting reduced here because of the external potential which is greater than that.